Assalamu alaikum. We are the students of BS Honor 3rd year presenting presentation on the topic reverse osmosis water treatment plant working. Topics that we will cover in this presentation are difference between osmosis and reverse osmosis. What is actually reverse osmosis? Brief history of RO, principle of RO, construction of RO, construction modifications, working, type of RO membranes, and the composition of membranes. Factors affecting performance of RO, applications of RO, advantages and disadvantages of RO. Reverse osmosis in comparison with water filtration, and RO plant companies in Pakistan. Difference between osmosis and reverse osmosis. Osmosis is the movement of water molecules from a lower concentration to higher concentration of solute through a semi-permeable membrane without any external force. As you can see in the diagram, there is no external force applied to the water molecules for their movement from lower concentration to higher concentration. While in reverse osmosis, which is an opposite of osmosis process, the movement of water molecules are from the higher concentration of solute to the lower concentration of solute through a semi-permeable membrane, but an external force is applied to the system to make the system successful. What is reverse osmosis plant? Reverse osmosis is a common process to purify or desalinate contaminated water by forcing water through a membrane. It is an effective water purification process that uses pressure to overcome the osmotic pressure and passes feed water through a thin membrane and removes unwanted particles, colloids, pyrogens, and bacteria. In reverse osmosis, as you can see, a pressure is applied to high contaminated concentration to pass through the semi-permeable membrane towards the lower contaminant concentration, and that is how the water is purified. The concept of RO was introduced back in 1950s, but it took more than 25 years to utilize it as a plant for purification. In 1977, Cape Coral, Florida was the first to use this RO plant on a large scale. Since its first application, Pakistan has 382 RO plants installed. RO works on the principle of osmosis, the natural tendency of water with dissolved salts to flow through a membrane from lower to higher concentration of solute. This process is found throughout nature. In RO system, pressure is used to overcome natural osmotic pressure, forcing feed here water with dissolved salts and other impurities through a high semi-permeable membrane that removes high percentage of impurities. Removal of contaminants from water. Reverse osmosis is capable of removing up to 99% of dissolved salts, particles, colloids, organic bacteria, and pyrogens from the feed water. Although RO system is not relied upon 100% of removal of bacteria and viruses. In RO system, it rejects the ion or any particle according to the size and charge. In an RO membrane, it rejects contaminants based on their size and charge. If the molecular weight of the contaminant is greater than 200, it is likely to reject it by the RO system membrane. As we know, the water molecular weight is 18. It can pass easily, but greater the ionic charge of the contaminant, more likely it would be unable to pass through the RO membranes. For example, a sodium ion is an monovalent charge +1 and it is not rejected by the RO membrane, as well as calcium ion with +2 charge is not rejected. Likewise, RO membrane also do not remove carbon dioxide, and that is why it does not remove gases. The chart, water filtration types versus size of common contaminants, describes the size of contaminants in microns and how they are being filtered by RO membranes according to their size. As we can see, the reverse osmosis, a nanofiltration can be seen as the particles are being blocked by RO membranes which are greater than 200 molecular weight. Different contaminants are being shown in this chart according to their size and how they are being filtered by RO membranes. Three things that need to be considered for better construction of RO plant. Quality of input water, required quality of pure water, required quantity of output water. After this basics, the plant is designed accordingly. Let's move to the basic construction now. The construction of RO plant is mainly depends on some parts. The parts of construction are feed inlet, feed water pump, pre-filters, anti-scalant, high pressure pump, reverse osmosis unit, reject stream, storage tank or outlet. Construction of RO plant. Construction of RO plant starts from a feed inlet. Feed is entered through here and to start the purification process of the water. Feed water pump. This is pump provide enough pressure for water to go through pre-filters. Pre-filters are different types of filters used in pre-filter treatments, usually multimedia filter, activated carbon filter, and softener filter. Anti-scalant can be used optional, but for larger RO system it can be used. Anti-scalant is a pre-treatment injected into the feed water before the feed water enters the RO membranes. Its presence delays the reaction between calcium, magnesium, and bicarbonate. High pressure pump. This pump is used to provide enough pressure for the water to pass through the membranes. Reverse osmosis unit. Reverse osmosis unit consists of brine seal, pressure vessel, and membranes. The most commonly used membranes are spiral membranes, ceramine membrane, stainless steel membrane, tubular membrane, hollow fiber membrane, plate and frame membranes. The type of membrane depends upon the quality and dissolved constituent of the feed water. Reject stream is the drainage outlet present to drain out all the impurities from the RO unit. Storage tank or outlet is the purified water now can be stored in the storage tank or outlet. Constructional modifications. There are several constructional modifications of RO plant. Among all of them, two have been discussed here: UV purifier and artificially mineral addition chamber. UV purifier is also known as disinfectant chamber, as all the microorganisms, especially bacteria, which have been left after the RO treatment will be treated in UV chamber and being killed. UV treatment ensures to eliminate all the microorganisms, making the water clear from any microorganism. But the bodies will remain suspended inside the water, as UV purifier cannot filter the water. It only eliminates the bacteria and microorganisms. It has been attached after a storage tank of RO filtered, as water should be clear for UV to work. The most important factor is that UV filter does not require any addition of chemical for the purpose, so there is no toxic byproduct in our water. Number 2 is artificial mineral addition chamber. As we know that water when passes through RO membranes, all the mineral, TDS, salts, ions are being removed. That is why artificial mineral addition chamber has been introduced. Working of RO plant is mainly depends upon four steps. Step number 1, pre-treatment. Step 2, high pressure pump. Step 3, membrane assembly. Step 4, post-treatment. Pre-treatment is the very first step to purify the water used to get rid of any impurity which can cause any damage to the membrane. Pre-treating the water results in removal of large solid particles such as sand, dirt, or other contaminations. It also helps in removal of chlorine, which destroy the membrane and cause poor quality of pre-made. For the pre-treatment of water, different types of filters can be used. Sediment filter out large particles like dirt, dust, and rust, etc. Carbon filter, it reduces the chlorine and volatile organic compounds, and it also gets rid of bad taste or smell of water. Other than these, water softeners are also used to remove any minerals in the feed. Different types of chemicals are used to inhibit the activity of bacteria or simply kill them to prevent the slime growth on the walls. Step number 2, high pressure pump. Since we have to provide an external force which will cause the water to pass through membrane and overcome the osmotic pressure, a device is needed to fulfill the condition. For the completion of the process, a pump is used to apply high pressure to the feed water. The typical pressure requires the seawater is ranged from 5.5 to 8 megapascal 800 to 1.180 psi. Step number 3, membrane assembly. After passing through the pump, high pressure causes the water to penetrate through the semi-permeable membrane, leaving behind the impurities like sodium, calcium, glucose, urea, bacteria, and viruses, etc. The particles which are too small to be seen by microscope can also be separated here. The purified water goes ahead while the impurities goes to reject or brine stream. Reverse osmosis is proved to reduce the quantity of lead, arsenic, copper, barium, total dissolved salts, and chromium. Although it does not reduce nitrate quantity, but it cannot reach the recommended level. Thin film composite cannot remove the chlorine from the water. That is why during pre-treatment, carbon filters are used for the removal of chlorine. Last step of RO working is post-treatment. A final stage before water is purified enough to be used is passing through a second or post-carbon filter, which will remove the remaining impurities and pure water will be obtained. This water can be stored in storage tanks for later use. The post-treatment will even get rid of any bad taste or odor, so that the water will taste incredibly fresh. We do post-treatment to ensure that water will be completely free of any pathogens or harmful impurities. Types of membrane used in RO. There are many types of membrane, each depends on salt rejection of water that enters it. The most common type of membranes are spiral membrane, ceramic membrane, stainless steel membrane, tubular membrane, hollow fiber membrane, plate, and frame membrane. In the diagram, we can see that the system costs have been described. That is, the tubular membrane is the costly, then plate membrane, then hollow, and the low cost is the spiral membrane. Susceptibility to fouling is also mentioned over here. Design feasibility, the most feasible is a spiral membrane. Energy use, tubular membrane use more energy and spiral membrane uses the less energy. So from all means we can say that spiral membranes are the most effective, low cost, and the best design feasibility and uses less energy as compared to all of the membrane types. Composition of RO membrane. As we have discussed in previous slide, the types of RO membranes, now the composition are mainly of two types, thin film composite and cellulose triacetate. The main difference between the two are filtration ability and chlorine tolerance. The cellulose triacetate can tolerate chlorine water, and the thin film composite cannot tolerate the chlorine water. The second difference is the cellulose triacetate can only reject 93% of standard contaminants, while the thin film composite can reject up to 98% of standard contaminants. If we see in the diagram right hand side, there is clear difference in their layer. If we see that when the feed enters, in thin film composite there is ultra thin barrier layer of polyamide and then the microporous substructure unit of polysulfone, while in cellulose acetate there is a dense thin layer and porous substructure layer. That means there are more spaces between the molecules. The similarity between them are non-woven support fabric, but in thin film composite a special material is used, polyester, which is today's used only for thin film composite RO membrane. In the third part, the third difference is being placed that the cellulose triacetate membrane had a low pH tolerance, that is why it is no longer used, while the thin film enables our system to make a lot of water in less space and making it possible to get larger membrane in smaller housings. Now the question arises, how often should we replace a membrane filter? Reverse osmosis membrane can be replaced after 2 or 3 years depending on the water quality. As the RO membrane rejects more minerals, some of those minerals start to come out of solution and clog the surface area of the membrane. If you feed the RO system with softened water, then the membrane could last 5 years if you replace the filters on a regular basis. Factors influencing the RO plant performance. Water pressure. High pressure is a driving force and the base of reverse osmosis. As we have discussed earlier, high pressure is required for the feed water to overcome osmotic pressure and cross the membrane. If pressure is not enough to overcome the osmotic pressure, then RO will not be successful. Number 2. Feed water temperature. The higher the temperature, lower will be the viscosity of water. However, flow of water will increase, which will make it easier for the water to permeate the RO membrane, and this will cause lower rejections of salt and permeate will be of poor quality. On the contrary, in winters, rejection of salt will be good and permeate will be of good quality. Number 3. Concentration of salt and TDS in feed water. The high concentration of salt and TDS in feed water causes increase in osmotic pressure, which decreases the permeate flow. High concentration also cause greater amount of salt passing through the membrane. Because of these two conditions, the product will not be of good quality. Applications of RO plant. Desalination of brackish water. Brackish water is water having more salinity than fresh water but lesser than the seawater. RO is an effective method to reduce its salinity and lower its saline concentration to 500 mg per liter. Desalination of sea water. 96.5% of all earth water is seawater. As the crisis of fresh water is increasing day by day, our best shot is to improve the methods which can purify the seawater. RO can be desalinate the seawater, but it is not as effective as Applications of RO plant. Desalination of brackish water. Brackish water is water having more salinity than fresh water but lesser than the seawater. RO is an effective method to reduce its salinity and lower its saline concentration to 500 mg per liter. Desalination of sea water. 96.5% of all earth water is seawater. As the crisis of fresh water is increasing day by day, our best shot is to improve the methods which can purify the seawater. RO can be desalinate the seawater, but it is not as effective as the evaporation process. Water production for everyday life. Although RO is not highly recommended for drinking purpose, it can still be used for many other purposes in households, example laundry, washing, cooking, etc. Spot-free rinse. RO is very useful in getting rid of all heavy metals and is free of any minerals that cause spotting. So the use of RO water is the source of cleaning is recommended. Food industry and pharmaceuticals. RO water is very purified, which can be used in both food and pharmaceutical industries to produce high quality products. Okay, application also have been described in the previous slide. In this slide, we will describe about the more explanated form of applications, how the applications proceed. Desalination of brackish water. Brackish water is water having more salinity than the fresh water, but not as much as the seawater, and helps in supplying communities that have the most difficulty in access to the fresh water. Seawater RO has a conversion rate of 35% to 40%. The conversion rate of brackish water from RO could be more than 90%. So it is the best application for drinking purpose. Although RO is not recommended as a drinking water purpose due to the less mineral and all TDS salts have been removed. Desalination of seawater. Seawater is also desalinated by the process of RO. Saline feed water is drawn from ocean and underground sources. The users of desalination overcome a major problem faced by many coastal communities that are having access to large supply of saline water but having no way to use. The product water from desalination process is water is less than 500 mg per 1 dissolved salt, which is suitable for most domestic, industrial and agricultural uses. So it is also a very helpful way to use RO treatment. Wastewater treatment. Reverse osmosis is widely accepted unit operation for water purification. The water is typically pressurized between 150 to 600 and passed through either thin film composite or cellulose acetate membrane, as we had discussed in the composition of membranes. It helps to decrease the impact on the environment by reusing sewage or industrial wastewater. In the conclusion, I would say the RO is doing its best for desalination of brackish water, seawater, and the treatment of the wastewater. So it is a revolutionary treatment. Applications have been discussed in previous slide and detailed, but now this slide explains the construction on the basis of different applications. Number 1 is the desalination of seawater and the construction of that RO plant. Number 2 is of the brackish water desalination and its construction, and number 3 is the wastewater treatment by RO plant and the construction for that purpose. Now let us discuss advantages and disadvantages of reverse osmosis. First, we go with advantages. Maintenance is very simple and it can be done when the system is still operating due to the modular design. Reverse osmosis does not require any addition of hazardous chemical for purification. It just filters out all the contaminate materials. Space requirement is low, so the system can be built on small areas. Many RO plants are designed to operate automatically, thus RO plants usually require less labor. Water from RO plant is not only pure but also free of any taste or odor due to carbon filters. Now, disadvantages. RO water is not recommended for drinking because human body needs some minerals which are stripped off of water by RO plant. Small holes in an old membrane can allow bacteria and viruses to pass through. It is an expensive process with slow output. It cannot separate carbon dioxide from water, which causes water's pH to drop. A lot of pressure and energy is required for the reverse osmosis to be successful. So these were the advantages and disadvantages regarding reverse osmosis. Comparison between reverse osmosis and water filtration. What is water filtration? Water filtration is the process of reducing or removing contaminants from the water by using a filter to physically block contaminants from coming through, as well as reducing chemicals through the adsorption process. Our carbon filtration method uses water pressure to force water through activated carbon filter, removing microorganisms, unpleasant water taste, odor, and contaminants. Chlorine, unpleasant taste, odor, dirt, sediment, rust, parasites, heavy metal, arsenic, and volatile organic compounds are successfully filtered from filtration process. Now let us discuss reverse osmosis. What is reverse osmosis? Reverse osmosis is the ultimate in water filtration. This superior purifying process provides the highest quality water conveniently at the turn of a tap. This membrane has up to 300% improved water efficiency in comparison to older style membrane, resulting in reduced wastewater production. It successfully contaminates or reduces the contamination of copper, fluoride, arsenic, barium, cesium, cadmium, turbidity, and chlorine more than 90%. Both are used. Water filtration and reverse osmosis both are used for water filtration, contain mostly one filter activated carbon. RO having semi-permeable membrane which reject type of contaminants like copper, barium, chromium, and total dissolved salts. So both have their own characteristic and principles. Activated carbon is used with RO to produce highly pure water as previously discussed. RO plant companies in Pakistan are RO Track Water Technology, Aqua Product Services Private Limited, Khas Trading, Pentapure Industrial Corporation, Skylark Engineering, Maxon Chemical Products Private Limited, Aqua Drops Private Limited, Water Care Service. All are one of the leading manufacturers and exporters of qualitative water treatment equipments and provide industrial water treatment products and services in Pakistan. Thank you so much, ma'am. This is all from our side. We are the students of BS Honor 3rd year, and these are the names of our group members. Thank you for assigning us this topic. The topic was very interesting, and we really enjoyed participating in it and gained a lot of knowledge by researching on this topic.